Hi, and welcome to this final video on the trigonometry section, and in this section we're just going to have a quick look at a modelling question, how they take trig equations, expressions, and put it into a context and ask you to interpret what's going on within that context. So here we go, there's the question, and what I've done is use the question where we've got an expression for the height of water given by this formula here, and we've got it in the form of an addition formula. But it's more than likely that you might have to do some work to get it into this format first of all. But like I say, I've not included that just primarily for the sake of brevity. We've seen plenty of examples of how we convert, like for example, a sine x plus b cos x into something that's a single trig ratio. So we've just got this trig equation here. It looks like a bit of a shocker, but let's not worry too much about it. Let's just crack on. Again, one step at a time. Here we go. Find the depth of the water at 4 a.m. Right. So we're told in the question the depth of water t hours after midnight. So at 4 a.m. we've got a value of t equals 4. So this is just a case of plugging that into our equation. And so there we go. So the 4 goes in here. So that gives us 8 in the bracket. And then just grab the calculator, whack it in, and you end up with the height of the water being 1.8 meters. Okay, that one's fairly straightforward so far. So on we go to part B. And part B says, what time does high and low tide occur, and how deep is the water in the harbour at these times? Okay, so again, we're not max-min, we're not talking about differentiation, and we're talking about, or we're looking at this function here and our understanding of the cos function, and we know that the maximum value will occur when this thing here, this cos thing here, is going to be 1. So h max is when the cos function is equal to 1. So we're dealing in radians here, so that gives us cos to the minus 1 of 1, which is 0 and 2 pi. And so we've just got to tidy that up now, and we end up with those two values. Now the problem we've got there is we've got t equals minus 4, which clearly can't exist. So what we've got to do is just keep going and replace that with that value in there. So 4 pi would be the next point, and so that gives us a value of t equals 8 and t equals 20. And again, when you write the answers, at what times do high and low tide occur, please make sure you put your answer in the context of the question. So the time it occurs is going to be 8 a.m. or 8 p.m. because t is how many hours after midnight. So let's just translate it back into time. Okay, so that's maximum. For the minimum, same principle, but this time the cos part of that function's got to equal minus 1. Again, work it through. So we end up with t equals 2 and 14. And so we've got low tides at 2 a.m. and 2 p.m. The question also then says, how deep is the water in the harbour at these times? Well, h max is going to be essentially when we already said that this thing here is 1. So what we've got is simply 3.2 plus 2.8, which is 6 meters. And for our minimum value is going to be 3.2 minus 2.8. So that's 0.4 millimeters. So there's our min and our max water levels within the harbour. Right, that's that bit done. On we go to part C, sketch the graph. So let's consider what's going on here. We've got essentially a cos curve, and it's got a vertical translation, which is that bit there. It's got a vertical stretch, which is that bit there. And then we've also got these bits in here, which are essentially a combination of a translation and a stretch in the horizontal direction. Those bits are less straightforward, but we don't need to worry too much about that, because as long as we can clock minimum maximum points, which we've already done most of the work for, we're going to be okay. So here we go with our sketch. So we know that if we're going to sketch a cos curve, you know, that value, if I'm sketching my cos curve, let's just do it over here. There you go. It looks like that. What I've done, this line here is essentially that one there at 0. So that's our horizontal translation. We've just shifted that whole center line on the cos curve and just shifted it up to 3.2. We've now got our maximum values. So when we had t equals 8, the height of the water was 6, and when t equals 20, the height of the water was 6. So let's just kind of put those onto our sketch. And then when we've got our minimum values, same principle, so let's put those on as well. and now we've got enough to be able to draw a cosine curve through there also. And the only other thing that I think we need to include is what happens when t equals 0, i.e. our intercept here. So when t equals 0 and when t equals 24, we've got h, and again just put t equals 0 into our expression, and we find that the height of the water was 1.8, and I seem to recall, I think we might already have had that from an early part of the question, can't remember. Anyway, so what we've got now is enough to be able to draw our curve through. There it is, there's our sketch. Okay, we're going to need our sketches to help us think a little bit about this last question. It says the boat has a draft of 2.5 metres, and if you're not familiar with the term draft, every now and again you see these words that are specific to a context popping up in exam questions, which is not entirely fair. But we're talking about kind of the vertical distance between the waterline and the bottom of the hull, i.e. it's how much water essentially needs to be in the harbour for the boat to be able to get in there. So there's going to be certain times of the day when the boat cannot be in the harbour, and that is when the water level is below 2.5, or put it another way, it can be in the harbour when the water level in the harbour is above 2.5. So we essentially need to know, when is the height 2.5? So that's what we're going to solve, and we can do it quite simply. Hopefully there's no major issues with all of that. We've got all our values again in radians. There's 4 values that are appropriate here, and now let's solve it. And the first thing we notice again is we've got a negative value for time, so that one's no use, so we'll have to replace with the next one up. And so there, what we've got is our values. And now if we have a think about those, and have a think about those in terms of our graph, we've got that value there and that value there, which means the boat can be in the harbour when the water level is above 2.5. And then the same thing is happening at the second period of a higher tide, so that's that period there. Last thing we need to do, again it says times to the nearest minute. These are not to the nearest minute, these are decimal. Time is not decimal, so what we've got to do is convert those to the nearest minute. So essentially what we need to do is take the 0.517 of an hour and times that by 60 to turn it into minutes, and then convert those into times, and there you go. So the boat can be in the harbour between 04:31 11:29, that's that section there, and then 16:31 and 23:29, which is that section there. And that's our question fully answered in context. Jobs are good.